Okay, before I build up the power supply, I just thought I'd show you the board. As you can see, it's got the SMD components that come with the kit already pre-installed, and just walking through those. So you have this is a 25 megahertz crystal right here. Here is the SI5351. Here is the dual D-type flip-flops that produce the 0 and 90 degrees LO. And down here we have these two are the FST3257s, the multiplexer, demultiplexer, and then finally we have the SA602 or NE602. So the power supply consists of, there's a jack here, there's a 2-pin header here that you install, a reverse polarity protection diode, there's some associated capacitors, and then you've got to get the location of these two regulators, U8 and U7. You've got to get them the right way around. So U8 is the regulator that's for 3.3 volts. U7 is the 6-volt regulator. You don't want to get those the wrong way around because you will blow up, likely blow up the SI5351. So anyway, I'll get on with building up the power supply part, and we'll come back and do some voltage testing. Okay, so just a quick update here. The jack's installed, this little jumper here, and the diode. Note the diode has the stripe facing upwards, and then note also with this is center positive. So anyway, let's test voltage. Got my multimeter down here, and if I probe here, I should see around about 12 volts, which I am seeing. So that part's good to go. I'll move on to the regulators next. So quick update. I'm not off to a great start here. When I connected up the 6-volt regulator, I noticed it was getting really hot, and so I shut it down. But then I noticed there was basically a short to ground from the output of the 6-volt regulator. And the only things that are really in the path of the 6-volt regulator at that point are these ICs here. So we've got this one's the D-type flip-flop. We've got the SA602 and the multiplexer, demultiplexer. So I've pulled with a hot air gun these three off here, and I found as soon as I pulled this one off, that short to ground from here went away. So I checked the IC, and the IC looks good. So I don't know, maybe if there was a solder bridge there or something. But anyway, what I'm going to do is I'm going to put this guy back on, carefully, of course, and I'm going to see if that short to ground reappears. Back later. Well, I've got that IC back on, but unfortunately the short to ground reappears. So not quite sure what's going on. Obviously very reluctant to blame the kit. I'm sure it's my fault. I guess that I somehow blew this chip by handling it. So what I'm going to have to do, I'll keep going, but I'm going to have to order some more of those FSTs. They're pretty easily obtainable, but it will take a while to come. So anyway, I'll keep going, and we'll take it from there. So as you can see, unfortunately there's a short between, well, it's hard to do this behind the camera, but between pins 15 and 16, you can see there. So this pin 15's connected to ground, so obviously this IC is no good. Now I'm kind of hoping the FST3257's are pin compatible with the FST3253s, because I've got a pile of them, but I'll have to check that and get back. So just checking the data sheets for the 3253 and the 3257, and unfortunately they are not compatible. I could actually, it's close enough that it would probably work, but I'd rather try the right IC. So as you can see, the difference between these two is for each of the outputs here, there's 2 pins. This is the 3256, sorry, each of the outputs there's 2 inputs, but for the 3253 there are 4. It's close, but it's not the same, unfortunately. So I do have to order some more. Okay, so let's keep forging ahead here and check. I've installed the voltage regulators, the 3.3 volt and the 6 volt regulators. So let's just check voltage output there. So first the 6 volt regulator, and you can see there's that's actually 6 volts, so that's correct. And then 3.3 is this pin right, this test point right here, and you can see there 3.3 volts. So both of those regulators are installed correctly, and we can keep moving on. Okay, so the microcontroller is installed. These 2 LEDs here are both installed. These 2 1K resistors here are installed. Switches S1 and S2 are installed. And then the pull-up resistors for the SCL and SDA lines from the microcontroller to the SI5351 are both installed. So that means the microcontroller section is already good to go. As I mentioned before, both this IC here and this IC here are already installed on the board, so you don't have to worry about that. So just walking through the positions of that componentry. So here's the 2 LEDs here. Note the flat side on the LED faces downwards. These 2 are the 1K resistors between the LED and the LEDs and the microcontroller. There's actually no silk screen here, so you have to. These are the 2 1K resistors. Similarly, here's the 2 10K resistors that are the pull-up resistors for the SCL and SDA lines, and again they're not silk screen, so just note the location of those. Here's the 2 switches here, and then the socketed microcontrollers right here. Now what we're expecting to see is the microcontroller is all ready to go, so it's already sending signals to the SI5351, instructing it to output the desired frequency, in this case 14.074. And then there are 2 test points down here which are the quadrature output of the local oscillator. So as I mentioned, it's not using the SI5351 quadrature capability. It's routing it through this pair of D-type flip-flops, and you get the quadrature output right here. So what I'll do now is I'll basically put an oscilloscope probe on each of those points and confirm we're getting the right signal output. Okay, so there's the 2 scope probes. I've got the 2 scope probes probing J6, as you can see there. It's turned on. I've got green LED, and looking over on the oscilloscope, we can see that nice quadrature, a bit crooked here, my apologies. So we can see that nice quadrature signal there at actually 14.0735 megahertz. Now there is a calibration function in there that allows you to adjust the output frequency, but that confirms that the PIC controller is installed correctly. The SI5351 is good to go, and that IC that I pulled before while I was doing troubleshooting, that's the 74AC74, that's good also. So making progress. What I'll probably do is wrap the video at this point. I don't need those FST 3257s till later on in the kit, so I can continue at this point, but ultimately I will get stopped until I'll have a replacement IC. Again, just to reiterate, it's full responsibility for me. I'm sure it's something I did. I don't think it was the kit at all. Like I said, this is part of the fun when you do the no manual thing, is you got to expect little bumps in the road. Anyway, that's all the fun, right? Catch you later.